Hello everyone. In the last class we studied about Sommerfeld's atomic model, right? That was just the development of Bohr's atomic model. We gathered informations how subcells make a cell or how subcells are present inside a cell, right? In this class we will discuss about quantum mechanical model of an atom. So let us first discuss how this concept was developed. We'll point out something, and straight we'll go to the Schrodinger wave equation and the idea of wave mechanical model of the atom, right? So the first point is Bohr's, Niels Bohr considered the electron just as particle, right? The first point is Bohr considered the electron as particle. If the electron is a microscopic particle, by Heisenberg's uncertainty principle, we knew that it is impossible to determine the position and momentum of an electron exactly with accuracy at a particular time, at a particular moment, right? So this is the next thing we should keep it in our mind. Heisenberg's first one is Bohr concept, then Heisenberg's uncertainty principle, said that the position and momentum of an electron cannot be determined simultaneously with accuracy. This accuracy, that means it gives an idea that determining the position of an electron inside an atom is too far difficult, exact position, right? So next consequence of this theory, this principle is that determining the exact position of an electron inside an atom is difficult. So if we don't know the exact position, then what should we do? The next step is we can rely upon the probability. We can rely upon the probability of finding the electron around the nucleus, within some region around the nucleus. What that we know, that the region around the nucleus within which probability of finding the electron is maximum is called the orbital. So cell, subcell then come to orbital. So orbital is the place where the electron can be found. So if we don't know the exact position, then let us rely on the probability of finding the electron. So this is the second point. So third point is, first Bohr, then Heisenberg's, then let's go to de Broglie's concept. Means the de Broglie's concept of dual nature of matter. So every microscopic particle or every microscopic particle has a wave-like character, having wavelength. What is the formula? As you know well, having wavelength lambda is equal to h by mv. For macroscopic particle, for big particles, this mass is very large, so that this lambda becomes insignificant, we can't observe. But for microscopic particle, this is not so much large, for which we can have the wave-like character for microscopic particle, like for us the electron. So for us, the microscopic particle is the electron, whose wavelength can be determined, whose wave-like character can be realized. So this is the third point. Okay, then if it is, then that means this point tells us electron has the wave-like character also, not only the particle. Okay, then fourth, electron moving around the nucleus, moving in a fixed orbit, around the nucleus, can be considered as standing or stationary waves, or time independent waves. Okay, so electron moving in a fixed orbit, that means when the electron is moving around the nucleus in a fixed orbit, its energy is fixed irrespective of the time. Whatever the time is, the energy of the electron while revolving around the nucleus is fixed. It is time independent. So this after these 4 points, so we will design a wave equation for the electron, that is called Schrodinger wave equation, which gives idea about the energy, the position, the momentum, angular momentum, and from that Schrodinger wave equation, the properties of the electron can be determined. Various properties of the electron can be determined. Like you have equation of straight line, like you have equation of straight line, like you have equation of straight line. What is that? Y is equal to mx plus c. Y is equal to mx plus c. This is y, this is x. Okay, so this is c and m is the slope. So like you can have various information about a straight line from the straight line equation y is equal to mx plus c. Similarly, you can get the position, the energy, the momentum of an electron and various other properties of an electrons from that Schrodinger wave equation when you solve that. Right. So let us now move to the derivation of time independent Schrodinger wave equation. Okay. So the Schrodinger wave equation is to be derived. So the next is derivation of Schrodinger wave equation. Schrodinger wave equation. So we'll start with, that means here also we will take the equation of a wave, a sinusoidal wave, which we generally use for standing wave, normal wave from physics. So the equation, we will start with the equation for a standing wave. Equation for standing wave has the form psi is equal to a sine 2 pi x by lambda. What is this a? This is the wave function. This is a. This a is the amplitude. This a is the amplitude of the wave moving sinusoidally in which axis? In x-axis. So this a is the amplitude of the wave moving sinusoidally in x-axis. We will start with the derivation, taking derivative of this psi twice. So let us have this. Now first derivative of this psi, d psi by dx. It will give you, this a will come out, it is the constant, so it will give you cos 2 pi x by lambda dot 2 pi by lambda. Right. We will have the derivative again. So we will have the d square psi by dx square. Again this a will come out, this 2 pi by lambda will come out. The derivative of cos 2 pi x by lambda will be minus sine 2 pi x by lambda. So we will have again this 2 pi by lambda factor will come. So it will give you 4 pi square by lambda square minus 4 pi square by lambda square and a sine 2 pi x by lambda. This is nothing but the psi. This is nothing but the psi. So let us write this a sine 2 pi x by lambda to be psi. So this will give you minus 4 pi square by lambda square, okay, psi, right? So let us now have the value of 1 by lambda square, because when we will go further, we will have somewhere to substitute for 1 by lambda square. So let us calculate what is, let us determine what is 1 by lambda square. So 1 by lambda square is equal to 1 by 4 pi square psi minus 1 by 4 pi square psi d square psi by dx square. 1 by lambda square here, 4 pi square psi going to that side. So 1 by lambda square is equal to minus 1 by 4 pi square psi. So what we'll do next? Next you see, we have kinetic energy. We have kinetic energy half mv square, right? And lambda is equal to h by mv. Okay, so you see, implies here we can have lambda square is equal to h square by m square v square. H square by m square v square. Okay, so from this lambda square, okay, lambda square is equal to h square by m square v square. Now this can be written as, you see, m square v square by 2m, right? M square, that means I have multiplied m and divided m. So m square v square by 2m. So here m square v square is nothing but h square by lambda square. Here you can write m square v square is equal to m square v square is equal to h square by lambda square. So you have here m square v square, and here this m square v square is equal to h square by lambda square. So let us put this h square by lambda square here. So it will be h square by lambda square 2m. H square by lambda square 2m. So using this lambda is equal to h by mv, kinetic energy is now determined. Now this 1 by lambda square, there is 1 by lambda square factor, and we have determined this 1 by lambda square. So let us put this 1 by lambda square is equal to this. After that, the kinetic energy for the electron will be determined, and then we will go to relate it to the potential energy and total energy. So you write, now we will write, so putting this value of lambda square, while you are deriving, give equation 1, 2, 3 like that. So but what we will do, let us put this 1 by lambda square to be this. So it will be, okay, so it will be 2m into 4 pi square. So 1 by lambda square is equal to this one. So let us write minus h square by 8 pi square, this 2m into 4 pi square, 8 pi square m psi d square psi by dx square. D square psi by dx square. Okay, so only d square psi by dx square is how much? D square psi by dx square is equal to minus, they are coming to this side, 8 pi square m psi by h square. 8 pi square m psi by h square, right? But this is the kinetic energy, right? Kinetic energy is equal to, so the kinetic energy is this much. So this equation and this equation to be equated. So d square psi by dx square is equal to minus 8 pi square m, this is coming to up, minus 8 pi square m by h square. Here is kinetic energy into psi, right? So 8 pi square m by h square coming to this side, so 8 pi square m minus 8 pi square m by h square psi, and this kinetic energy is nothing but implies d square psi by dx square is equal to minus 8 pi square m by h square. Kinetic energy and potential energy, the sum of the kinetic energy and potential energy give you the total energy. If we will subtract the potential energy from the total energy, that will give us the kinetic energy. So minus 8 pi square m by h square E minus V psi, right? So let us take the right side to the left side, then we get the final equation to be d square psi by dx square. So coming to this side means plus 8 pi square m by h square E minus V psi is equal to 0. This is the Schrodinger wave equation for the electron for any microscopic particle in x-axis. But if we will consider the movement of the particle in all three direction x, y, z, then this is the one dimension, for Schrodinger wave equation for one dimension. So we will write for 3 dimension, we will have d square psi by dx square plus d square psi by dy square plus d square psi by dz square plus 8 pi square m plus 8 pi square m by h square into E minus V psi is equal to 0. This is for the 3 dimension. Okay. So instead of this 3 term, we can write, instead of this 3 term, we can have del square psi plus 8 pi square m by h square into E minus V psi is equal to 0. So this is the Schrodinger wave equation for particle in 3 dimension. Okay, so thus we derived the Schrodinger wave equation. So this is the most important part of the wave mechanical model of the atom. As I said before, that by solving this equation we can have various properties of electrons. So we will see in the next class what is psi and psi square, and again then we will move to the eigenvalue and eigenfunctions, then go for the solution for the hydrogen atom using this Schrodinger wave equation. Thank you so much. We will discuss in the next class.